So we're going to look at the solubility and saturation of solutions. Before we discuss that, though, let's look at a few terms that we've been using and make sure we're on the same page for them. So remember, a solution is whenever we have any kind of homogeneous mixture. That means it's the same throughout the whole thing. The components are the same ratios throughout the whole mixture. And we have two key components to any solution. We've got the solute, which is the substance being dissolved, and we have the solvent, which is in greater amount, and it's doing the dissolving. So remember, we dissolve the solute into solvent. And we can measure the maximum amount of solute that can be dissolved at a given temperature, and we call that the solubility. That's when we reach the maximum amount we can put into that solvent and still dissolve it all. We express the solubility in terms of grams of solute per 100 grams of solvent. So you'll always see some number of grams over 100 grams of solvent. Typically that solvent is H2O, and you're going to see again a certain number of, for example, the solubility of oxygen can be 0.070 grams per 100 grams of H2O. So you see you actually have that first value, which is the mass of the solute, and then you have the grams of solvent, which is typically 100. And you got to remember that the amount will change depending on how much solvent you have. We also have three key levels that we use to describe the different saturations or solubility of a solution. Now, if you have not reached that solubility, we say that the solution is unsaturated. You have not reached the maximum. You right now have less than the maximum amount of solute in it. And so if you put some of your solute into the solution, it's all going to still dissolve. More solute will dissolve in an unsaturated solution. But at a certain point, you're going to reach that maximum amount, and then that's when you have your saturated solution. A saturated solution, when you continue to put solute into a saturated solution, it's not going to dissolve. It's going to instead sit at the bottom and collect, and you will not have any more dissolving. And you've reached that maximum level. No more can be dissolved. Now, in certain cases, you can produce super saturated solutions. This is where you have more than the maximum amount. And you can only get this through a series of heating and cooling. So what you do is you get a solution to the saturated level, then you heat it up where it has a higher solubility, and you can add even more solute into it and dissolve into it and get it a higher level, and then lower the temperature. So now it's got more than it should. As a result, it's very unstable and crystals can form very easily. Here's a little GIF to show you a supersaturated solution solidifying, where you have the solute precipitating out. You can see it happening very quickly. All you have to do is add just a very tiny, what we call a seed crystal, and then you'll start to form all of that solute that shouldn't be in there, shouldn't be dissolved, will start crystallizing out. Now, we can use what are called solubility graphs to determine the amount of solute in grams per 100 grams of solvent that can be dissolved. Over here on the right is an example of one of these solubility graphs or solubility curves. This one is for potassium nitrate. And the curve of a solubility graph tells you the saturation point for the solute. So this line here, this curve, is telling us the saturation level. So any point on this curve will tell us what the saturated solution is at that given temperature. So for example, if I go to 50 degrees Celsius, I see that in 100 grams of water, I can dissolve 90 grams of KNO3. And looking at this graph, any points below those values, so at this 90 grams. Anything below this area here, we'll say it will be unsaturated. So anything less than 90 grams at 50 degrees can still be dissolved. Any point higher, the only way to reach that is to do a supersaturated solution. So you have to, again, do that key of going to a higher temperature to add more and then lowering the temperature, and then you're at a point where you have a supersaturated solution. So here's an example of multiple solubility curves on one graph. We've got 6 different substances being compared. And let's go through some examples of what kind of questions that might be asked. So let's go ahead and try some of these sample problems. First question asks us what mass of KBr will dissolve in 100 grams of water at 40 degrees Celsius. So the key on these is first to identify what is the substance of the solute that we're looking for when we have more than one solubility curve. We also want to verify what is the amount of solvent, usually water, and then what's the temperature. If you look at the chart, we'll see that the chart is in per 100 grams of H2O. So since we're looking at 100 grams of H2O, all we have to do for this problem is find our point on the graph itself and read it off. So we're looking for KBr. KBr is this green line right here, and this green curve. We are then looking at 40 degrees Celsius. So find 40 degrees and where does it hit the green curve, which is at this point right here, which is slightly below the 80 grams. And so it's going to be between 77 to 78 grams is where that point's hitting. Now, sometimes they will give you a different amount of solvent. So here we're following the same pattern with this question. It says, what is the mass of NaNO3 that will dissolve? But now it's saying 400 grams of water at 10 degrees Celsius. So again, we're going to follow the same pattern. Identify what curve we need. We need this NaNO3. And we're going to look at where it hits that red curve, because that's the curve for NaNO3, specifically at 10 degrees Celsius. So I find 10 degrees Celsius, move up, and it's hitting right at about 80 grams. But that's for the 100 grams. It's asking us to find for 400. So what we have to do is figure out how many times does 100 go into 400. So I divide 400 by 100, which gives me 4. So I need to then take that 80 and multiply it by 4, which gives us 320 grams. There's the amount that will dissolve in 400 grams of water. The next question asks us to do kind of the reverse. So again, it asks us to find the temperature that only 20 grams of KNO3 will dissolve in the 100 grams of water. So now we're looking for KNO3. That is this blue curve. But we're not given a temperature this time. Instead, we're given the grams of solute, which is 20. So we're going to start here and work our way on this blue one to see where it hits, what temperature it hits that blue line. So I come in here, it's here, which happens to be at 10 degrees. Therefore, it's at 10 degrees Celsius. If this had been anything than 100, I would have to have divided the number, or see how many times 100 goes into the amount of water it said, and then use that number to divide that number as well. So keep that in mind. Let's look at 2 more problems. So let's look at number 4. Number 4 is asking us 100 grams of water is used to make a saturated solution of KNO3 at 10 degrees Celsius. How much more grams of KNO3 could be dissolved if the temperature is raised to 70 degrees? So Again, we're going to take a look. It's saying 100 grams of water, so we won't have to multiply by any values. It's telling us to start with the curve for KNO3. So we're looking at this blue curve again. And we're going to start at 10 degrees. So look at 10 degrees where it hits it, which happens to be at 10 degrees, it's at 20 grams. But then it's asking us how much more will be dissolved if we go up to 70. So now we're going to look at what it is at 70, which is right here at this point, which is 120. And it wants to know how much more, 120 grams. So what we have to do is find the difference. We have to subtract. We're going to take the 120 and subtract that 20 grams. This one, by the way, is the 70 at 70 degrees, and the 20 is at the 10 degrees. And we end up with 100 grams. That's the answer it's looking for. Even though it gives us the values of 120 and 20, it wants the difference. So we need to make sure we report the 100 grams. The last question is more of a comparison. So we're going to be looking at all of these that are listed, and it wants to know which one is the most soluble, which one has the highest solubility at 80 degrees Celsius. So here we're going to find 80 degrees right here, and we're going to go up and see which one hits at the highest point. So coming up here, I see that the dark blue curve is the highest one, and that is the curve for KNO3. So KNO3 is the most soluble at 80 degrees. So use these examples to help you when you are asked to do any solubility curve analysis, any questions involving solubility curves.